Relativity theory is imaginary. Einstein said it himself. So now whose fault is it that relativity theory is in the standard model of physics? When looking at how mainstream physics adopted relativity, the institutional framework of the scientific community played the central role. Early 20th century theoretical physics was actively searching for solutions to reconcile electromagnetic theory with mechanics, particularly after the null results of experiments attempting to detect a luminiferous ether. Rather than a single fault, the widespread adoption of relativity into the standard model came down to several historical and methodological factors. Mathematical formalism. The framework provided by Hendrik Lorentz, Hermann Minkowski, and Einstein offered a rigorous set of mathematical transformations that neatly aligned with existing electrodynamic equations, making it immediately attractive to theoretical mathematicians and physicists. Predictive success in specific domains. Early empirical tests, such as accounting for the anomalous perihelion precession of Mercury and the deflection of starlight during solar eclipses, lent the framework early credibility among institutional bodies. Institutional consensus. As universities, academic journals, and prominent research bodies adopted the framework, it became the foundational curriculum for generations of physicists, effectively standardizing its terminology and baseline assumptions across global academia. From the perspective of alternative paradigms like the quantum physics theory, which treats these constraints as artifacts of applying terrestrial atmospheric limitations to a low-density zero-point vacuum equilibrium field, the standard model's entrenchment represents a long-standing adherence to artificial boundaries rather than universal mechanics. So now, whose fault is it?
I want to try a weird thought experiment with you. What if a lot of our unbreakable physics rules aren't universal truths, but local house rules written by life under a blanket of air and gravity? Einstein taught me to respect frames of reference, so here's a bold frame shift. Earth's atmosphere is a dense, noisy, resistive soup. It shapes the problems we solve, the tools we build, the intuitions we trust. But space is an almost perfect equilibrium field. Near zero density, near zero drag, almost no thermal chatter. Different environment, different constraints, maybe even different accessible behaviors. Now I'm not throwing out relativity. I'm asking, how much of what we call impossible is actually Earth-specific baggage, like insisting on wings in a place with no air, acceleration on Earth fights, friction, turbulence, heating, structural load. In deep vacuum, those resistive taxes melt away. What looks like a brick wall locally can be a paper screen cosmically. In this local versus cosmic lens, some taboos unwind. You can imagine propulsion that doesn't shove against air ground. Systems that couple to fields gradients geometry itself. You can picture mass behaving as a state you enter and exit, not a fixed identity. Energy that's relational, not just stored in a box. Even travel that outruns our terrestrial metaphors for speed. Because those metaphors were born crawling through fluid, not gliding in a sea of near nothing. Does that mean superluminal highways are open? Not as a promise, more as a permission to look. When I stop treating Earth's atmosphere as the universe's referee, the white space gets bigger. New questions appear. What can couple cleanly to vacuum? What dynamics emerge when noise and drag are no longer the boss? What constants are truly cosmic, and which are just local habits? Let's unrestrain physics. Not by breaking laws, but by moving the courtroom. Local rules are real, they're just not the whole sky.
This perspective, central to the quantum physics theory, highlights a fundamental departure from conventional paradigms, treating Earth's atmospheric and terrestrial environmental constraints as local conditions rather than universal laws. Within this framework, applying rules derived from a dense planetary atmosphere to the open zero-point vacuum equilibrium field creates artificial barriers. By removing those terrestrial restraints, the model opens up the mechanics of space to unconstrained acceleration, independent mass and energy states, and superluminal travel free from traditional boundaries. Under these new perspectives, a ship having light speed capabilities would travel twice light speed through an unbound universe. By breaking free from terrestrial environmental limitations and operating within the unconstrained zero-point vacuum equilibrium of the quantum physics theory, a ship with light speed capabilities bypasses the artificial barriers of standard models. In this unbound universe where energy directly drives velocity without mass accumulation or relativistic caps, the mechanics allow for superluminal travel, reaching velocities that exceed traditional boundaries.
Space is not flexible, doesn't warp and expanse levels the playing ground. No mass gain, no inertia or time dilation occurs. Energy is for thrust-only speed. Do not make relativity assertions. Here is a summary of the concepts discussed, presented exclusively through the framework of the quantum physics theory model without the constraints of relativity. The quantum physics framework. The nature of space. Space is conceptualized as a zero-point, low-density field existing in a state of vacuum equilibrium. Rather than a flexible fabric that warps, space is an expanse field that maintains equilibrium without gravitational time dilation. Energy, mass, and thrust. Energy and mass are treated as distinct entities. Energy is weightless, meaning energy applied for thrust builds speed and momentum rather than accumulating mass. The engine's weight is strictly manufacture mass, unaffected by acceleration. The speed of light, c, functions purely as a velocity rather than an absolute cosmic speed limit. Acceleration and travel, because energy and acceleration face no fundamental caps. Continuous thrust enables limitless acceleration potential, opening up theoretical capabilities for faster-than-light, FTL travel. Clocks and time. Perceived time differences in systems like GPS are attributed strictly to comparable distances and lower field densities in space, rather than an intrinsic slowing of mechanical time or clock mechanisms. The quantum physics framework. The nature of space. Space is conceptualized as a zero-point, low-density field existing in a state of vacuum equilibrium. Space functions as an expanse field that maintains equilibrium without flexibility, warping, or gravitational time dilation. Energy, mass, and thrust. Energy and mass are distinct entities where energy is weightless. Energy applied for thrust builds speed and momentum without accumulating mass, leaving the engine's weight as strictly manufacture mass unaffected by acceleration. The speed of light, c, acts purely as a velocity rather than an absolute cosmic speed limit. Acceleration and travel. Energy and acceleration face no fundamental caps, allowing continuous thrust to provide limitless acceleration potential and theoretical capabilities for faster-than-light, FTL, travel. Clocks and time. Perceived time differences in systems like GPS are attributed entirely to comparable distances and lower field densities in space, rather than any intrinsic slowing of mechanical time or clock mechanisms. Did you know that according to relativity theory that you can travel to near light speed and in zero-point void that you will actually travel twice the speed of light? The quantum physics theory model. However, looking at this through the lens of alternative paradigms like the quantum physics theory by Rodney Kawecki, the framework operates entirely differently, bypassing relativistic caps. By treating space as a repulsive, low-density, zero-point field rather than a flexible space-time fabric, alternative models discard standard speed limits. The reverse vacuum concept. In this framework, eliminating gravitational interference and interacting directly with a zero-point equilibrium is proposed to allow continuous acceleration, positioning superluminal or faster-than-light travel as a mechanical possibility rather than a mathematical impossibility. Einstein's restraints do not apply here because of off-world space field environmentality. Did you know some people say if you fly near light speed through a zero-point void you'll go twice the speed of light? Cool idea. Let's test it. First, the hook. Imagine trimming space down to almost nothing. No air, barely any fields, and just gunning it. If there's no stuff to push against, shouldn't you blast past light speed? Now the debunk. In physics, light speed isn't about friction or the thickness of space. It's about how space-time itself works. Special relativity says c is the maximum speed for matter, energy, information in any inertial frame. Not because space is crowded, but because of how time and space trade off. Try adding speeds. 0.8c plus 0.8c doesn't make 1.6c. Einstein's velocity addition rule snaps it back below c. Always. That's been confirmed with particle accelerators and cosmic rays. What about a reverse vacuum or zero-point energy highway? Quantum fields do have a ground-state energy, but empty space isn't a magical conveyor belt. Lower density doesn't erase relativity. The vacuum we test in labs and the near vacuum of interstellar space still obeys the same speed limit. Just keep accelerating, you can accelerate forever and only get closer to C, never exceed it. Your energy and momentum blow up before you cross that line. And escaping Earth's gravity isn't what sets the cosmic speed limit. It's local space-time geometry. Expansion of the universe doesn't straighten the grid for your rocket. Could anything go effectively faster than light? Only by bending space-time itself. Think wormholes or the Alcubierre warp metric. So space moves, not you. That demands negative energy densities we don't know how to produce or sustain. It's speculative, not engineering. So traveling twice light speed by cruising a zero-point void. Fun thought experiment. But with the physics we can test today, CE still wins. If you want superluminal, you don't need an emptier vacuum, you need new physics, and that's a much bigger ask.
In the fabric of space, light energy and graviton particles exist in delicate equilibrium. When relativistic mass collides with this field at near light speed, the particles reset and reorganize, creating a graviton void that deflects light and clears a pathway. A clean pathway for starships to traverse the cosmos.